Today we are going to talk about closing the seed trench and checking the population. Hi, I am Roger Hardaway, in the sales department at the Concordia location. So closing the seed trench, this is what we're actually looking for as we are going through the field. So first off, we need to look at the toolbar itself and make adjustments to get the toolbar between 20 and 22 inches off of the ground when the planter is lowered. So if we need to adjust this on, say, a 1770 or a 1775, there's going to be 4 bolt holes on the carrying wheels on each of the 4 or 6 carrying wheels or 8 carrying wheels, depending on which you have on the row units, or not the row units, but on the carrying wheels of the machine. On a 1720 or 1700 planter, this would be with the gauge wheels that are in the middle of the planters that actually be the drive wheels on that 1720 or 1700. So the next thing we do is we step on over to this bar to make it plumb. So first off on a 1720 or 1700 planter, which would integral planter, we would actually use the third link of the tractor and push it back to change this bar to make it plumb. On a 1770 or 75, we will lower this hitch to keep this bar plumb as we're going through the field. And in turn, when we do this and get the height set, this row unit will be perpendicular to the ground for the planting depth. So first off, let's cover closing wheels. We have our standard rubber tired closing wheels up here in the top left. Each one of these, we have a cast closing wheel that we can actually factory install. A lot of what's happening now is on this is a copper head. This is the actual closing wheel tires, and then there's plastic ring. You unbolt this and you can add this into that to make those closing wheels with spikes on them. The other ones that of course, here's the Deere rubber tired wheels. There is a Dawn rubber tire closing wheel. The other options are Dawn. This is a cast closing wheel. Both of these are cast closing wheels. This one actually has about an inch across the surface of it, so it actually works as a gauge as a gauge wheel, so the depth won't only go down to where the claw is. So if we look at what the trenches are going to look like after we've closed them, this would be a smooth tire wheel, which would be one of these. This on this side would be one of the spiked units closing this and both of them are virtually in a no-till situation. So the next thing we need to make sure as seed trench is cut, our closing wheels are directly over the center of and centering that seed trench that's cut by the True-V disc. And by doing that, we're lowering the planter in the yard clear to the ground. We don't have to put all the pressure on it, but we need the disc to cut and touch in the ground. And then we check the distance on each side so that it's directly centered to the rubber closing wheels. On this picture, we can see up in the front on the top, you can actually see the bolts to adjust this. So we can loosen these bolts. There's lock nuts on them. They will not fall out. But once we loosen these bolts, you can see that they are rounded on each side, and so we can center these rubber closing wheels. Next off is the spacing of what the closing wheels have. On a standard, what would come out from the factory, we would actually have these bushings would be between the cast and the rubber tired wheels. If you would want, you can actually take the bushing and move it to the outside and put these wheels almost touching. The next option is going to be offsetting the closing wheels in case we have root balls or other foreign material that's getting wedged in between this area, and we can move one forward and one back. Next off, let's look at the downforce of how we would actually increase the downforce on the system. So this would be a standard system with a mechanical downforce. So here in the center where it's red, that would be 0 downforce unless you had a set of cast wheels closing the trench. With the cast wheels, it can actually be the weight of what the cast wheels are to increase that actually puts downforce on before we mock it into a notch here. So with this, normally this is the lowest setting here in A and the highest setting here in D. What we're going to remember is each one of these notches is 25 pounds more. So now what is an option that is out there is pneumatic closing wheels, which is done by the pneumatic air compressor for an active downforce. If we had an active downforce on the parallel arms, or if it's just a hydraulic system now and it has these pneumatic bags, it has this compressor on the back. So with that, we get 25 different pneumatic closing wheel downforce settings that we can actually adjust from the cab to plus or minus. And in that being said, we have 2 groups of downforce. So the group A or group 1 would be your 2 wings, and group 2 would be your center section around what your tractor's traveling if we need to feel like we need to change the setting. And this would actually be looking at seed star 3. So setting up the planter, the sequence before we go to the field settings. First off, we know we need some form of weight on the wings. This would be with markers. This would be with weights, and this would be frame weight distribution, which would be an option on a 24-row planter that is being built today. Second off, we have the downforce systems. This would be the hydraulic system that we are running, and this would be the pneumatic system. So we have to choose at least a setting and say a poundage that we're going to put downforce on whenever we start in the field. So the next thing is we need to know where our row cleaners are going to be run. So we need to make them set as we're getting ready to practice to get our right before we're starting to plant. We need to know how much downforce we're going to put on this, how much dirt we need to move on this setting. Next off, we need to set the closing wheel downforce. So if we think we can get by in the first notch, second notch, whatever, we need to set something there so that we're actually closing the trench. And then the other option is going to be, of course, the pneumatic, so we can go in to this screen and tell it that we want it to, this would be our target, that we want 2 pounds of downforce on this. That wouldn't be, I mean, normally we'd start out at say 35 to 50 on downforce. So what we're actually looking for whenever we get this, we're going to adjust this system on the downforce to make our trench and everything closed look like this, and we recheck it, the row unit, after we've actually done this to make sure that we're achieving the right ideal margin on these trenches as we're going through the field. So we've got everything set, we've planted, and we've practiced. So now we need to look at this and see where we're actually, what our trench actually looks like as when we've stopped. So we've driven, we've stopped the planter, left it down in its plant mode. We come back and we look right here in front of this trench, or behind the gauge wheels and in front of the closing wheels, to see what our trench looks like, to make sure that we're not knocking dirt into the trench or anything else before it gets to here. So the next thing is we're going to count the seeds in the field. This gentleman's looking to make sure that we've got the seeds in the trench, and also to make sure that we're not putting too much compaction on this right in here. The easiest way to count seeds, of course, is going to be locking our row units up and making our trench look like this, and then we can walk down along and we can count our seeds. So checking the seed trench after we've locked these up and we want to count our seeds. So on a 30-inch planter, we would actually flag 17.4 feet and check the numbers of seeds that we've planted in that 17.4 feet and multiply them. It'd be 1/1000th of an acre. So if we wanted to look at it in a broader scheme, we could actually mark off 87 feet, and that would be 1/200th of an acre. So in everybody's operator's manual, you have everything in detail of how all of this is done. So everybody's seen this picture in our operator's manual, knowing the seed disc and the vacuum and everything that there is to do to get this set the way you want it to going through the field. So now on the ground drive planters, we could have approximately 12% of drive wheel slippage. So we need to be able to check this. So we mark one of the wheels on the planter and we rotate it 30 times, driving with the planter up and checking the to get a baseline. We actually put a flag at each spot where we started and where we stopped. Next, we turn around and we lower the planter at the first flag and we count the number of revolutions, and stopping at the second flag to see where our tire is in relevance to the amount of slippage that we have in the planter. So this is closing the seed trench.